Hey, welcome back to Object-Oriented Programming using Java. This is the second part of defining classes. Last time we were here, we talked about how a class is a blueprint. And I actually added a couple of more methods to my class. And I'm going to change a couple of things here just so I can talk about what the initial concept about object-oriented programming, which was encapsulation. We originally had this method called writeOutput, and this would, if we call this method, then we would just write this out, the data that we have as properties here. So you remember from last lecture, these are instance variables for the class, and what we want to do is we just want to print them out. I did add an additional method called readInput, and it basically just reads the input from the keyboard. So I used the scanner class, and then I new it up by saying new scanner that instantiates the object, and then I'm able to read data from the keyboard. Now, if you don't understand what instantiates the object means, we're going to go back to that in a little bit. Okay? We're going to define that word and what that actually means. And then lastly, I have two more methods which return an integer data type. And it basically just returns the day, the instance variable day, and the instance variable year. Now, the reason why I declared the method called getDay and getYear and did a return on that is because best practice when defining classes is by making your instance variables not public but private. And private is a keyword that we use for access modifiers to indicate that these variables are not accessible outside of this class. And we'll talk a little bit more about access modifiers as we go through this lesson. So just hang tight, okay? If you notice, my class has an access modifier that's public, and what that basically means is that anybody can declare it or access it. If my class was private, then nobody can access it. In this particular case, we've made a couple of all the methods that I've defined as public, which means that if somebody declares my class and wants to use it, then the methods that are available to the caller are writeOutput, readInput, getDay, and getYear. It would be different if I mark these as private. If I mark this as private, then I'm encapsulating the method from the caller. And there are instances where you may want to do that, where you want to encapsulate a method and not expose it to anybody except the class itself. So we're touching a little bit upon access modifiers. So I'm giving you just a little bit, little by little. Okay. Now, again, I said that the instance variables of a class, best practice would be to keep them private, and the only way to expose them to anybody that wants to use your class would be to have use the method that returns the actual instance variable. And usually, if you do mark these private, then you would need a way to return the value of this instance variable to the caller. And the way to do that is you'll just create a method, a getter method called getDay. Now, along with a getter method, you'll usually have a setter method as well, so you can set the value of day. But we'll talk about that in later lectures, but I'm just giving you how things will eventually be structured. In this particular case, we have a getDay, which is public, meaning public, remember, it's accessible to everybody. And we're returning day, which is day in itself is a private instance variable, which means that anybody that declares our class and tries to access this property directly, is not going to be able to, because it's declared as private. And I'll show you an example of that in a bit. But if we want to access the value of day, then what we would do is we'd create an object of this class, and then we'd call this method to get it back. As simple as that. Okay. Now, this class currently is just a class, so it's a blueprint that's going to be used by somebody else for whatever reason. So in this case, maybe we just want to have you have a use case where the user needs something to read in a date and then just get the data back, where you want the day and the year back. Okay. Now, usually when you write out a class such as this, you'll have something called either a main or some type of main centered class, where you're going to call all these classes that you're going to use. And most likely is these are classes that you're going to instantiate an object of the classes that you've defined. So think of it this way, where if you have a blueprint of a house, and the blueprint is not going to come to life until somebody actually builds it, right? Somebody builds a house out of that blueprint, which means that some contractor has to get this blueprint and create the actual physical representation. So that contractor is your main. Okay. For now, well, let's think about it that way. Eventually, it's going to change a bit, but so your main class. Okay, now you don't have to call it main, but remember, name of the class has to be the same as your file. So your main class is your contractor. So this is the person that's actually going to take your class, take your blueprint, and then instantiate the object of the class. So this is actually what I want you to pay attention to, and we're gonna take this and dissect it so that you understand what instantiation means and what we're doing with the code. All right, so let's take a look here. So this is your main class, and it's your contractor, right? This is the one that's actually going to build the physical representation of your class. So if you take a look at this line here, okay, this first line here, this is what we call creating an instance of an object. It basically means anytime you see the word new, what this is doing is it's taking your blueprint. So let's just draw a little picture here. You know, I like to draw pictures. It's taking the blueprint of your class, right? So however that looks, you know, we have class, public, class, and then date try first, right? We saw the definition of that in Replit. Sorry for the handwriting. Okay, we're taking the blueprint, and then when we new it up, right? The minute I say, okay, new this up, we're actually going into heap memory. So let's just do RAM here. Well, let's not talk about heap, but let's just talk about RAM. Okay, we're actually creating a reference to it, and we're allocating it in RAM. So what's happening now is that we've instantiated an object, okay, and think of that object as lying in like maybe this part of RAM. Okay, let me make it red so that you understand it better. So if we take RAM, right, my object of the class is represented physically by this space in RAM. And well, what's stored in that? Well, what's stored in that is, if you remember from C++, right, and you declare a variable, then that's got to be stored somewhere. So maybe you'll have a section that has instance variables, right, which are your properties. Then you'll have a section that stores your methods, right? The methods that we wrote. And then somewhere here you'll have also a section of RAM where you're going to store the other class instantiations, right? So in this case, we instantiated scanner, right, in our class. Now we have a live class in memory that's ready to go. So anytime you see the word new, we are creating an instance of this blueprint and physically creating it in RAM. And if we don't do this, right, if we just try and do, if let's say my code, right, was just, it looked like this. So let's say I just did this. So date first try, and then I did date 1. Okay. Notice how I'm not doing any new here, right? So what this is doing is it's taking the blueprint, right? We'll just use the same blueprint. And instead of pointing at something in memory, it's actually pointing to null. Okay. And if it's pointing to null, if I try and say date 1 dot read input, we can't do that, right? Because there is no physical representation of this class. Hence, you get a null pointer exception. So if whenever you run into this type of issue where you're declaring so this is what we call a reference type, right? Date 1's reference type is date first try, which is the class we built, right? But there is no instantiation of the class because we don't have the word new here. And because there's no instantiation, then date 1 now points to null. And thinking in terms of blueprints, the blueprint now really points to null. Hence, we don't have a physical representation. Hence, we really cannot access any methods in the date first try class. Okay, so I'm going to erase this, but just so for your notes, this is called a reference type. Reference type. Okay, so when you're trying to build an application, you're gonna have a declarations of classes, and when you declare your classes, you're gonna this name here is anything you want it to be, right? But to the left of that, you have to put a reference type, and those reference types will either come from pre-built classes such as scanner, right? Or they'll come from your class that you've created. Okay? So I hope we're clear on that so far. Okay, I hope you're clear on that so far. Let me just erase this real quick. Okay, great. So now we have an instance of the class object, right? We've created the objects, and now because of the word new, now this line is accessing the method called read input. Now remember, read input, if we look back at our declaration of our class, read input was the access modifier was public, so we're allowed to use it, right? Because it was public. This will call that method, and we'll run it in a bit. Once we call that method, in this line, we call another method which just gives me the day, right? So this get day, which is one of the methods over here, is returning the value of an instance variable. Because remember, we changed day to be private, not public anymore. Okay, so through the methods, I'm able to access my instance variables that are right here. Let me do this a little neater so that you're not. Let me do this a little neater here. Okay, so in the first section, okay, so that looks a little bit better, but so instance variables, methods, and objects. And to objects, I give you an example of that. there's an object instantiation that happens in read input, and we'll look at that in a little bit. Okay, so get day gives us the value of an instance variable because it's marked private, and we want to encapsulate that. We don't want anybody to be able to do date one dot day. Okay, we don't want that. We don't want people to access your property like that, because then there's no control over that. So you want to hide your instance variables as much as you can and not have them be accessible to anybody. The only way that you have control over that is by marking the instance variable as private with the access modifier. And then if a user wants access to that, in this case the caller, we'll call user the caller. Let's say in this case we want the value of day. We just call the method called getDay and we expose it that way. So you need to have control of the things that you want to expose from the class. What we do here is, so this is a no. Okay. What we do here is we get the value of day, and then we store it in a variable called day number. And then now we can use this day number in our main class just to print out that is the whatever 4th day of the month, 3rd day of the month. So we'll look at an example for this as well. Okay. And I hope this is clearing up what defining classes means and then what creating an object of a class means, right? In terms of building software, when you're building an application, step one would be, define your classes. And this define your classes can be broken down into so many tasks. But again, let's just be high level for now because we're still learning. And then once you define your classes, your main will instantiate objects of your classes. And when I say instantiate objects of your classes, it means that take the blueprint, right, of your class definitions and slap them on memory so that I'm able to use them. And when we instantiate a class, we mean we new them up. We use the keyword new, and that in turn will create an object in memory. So let's take a look at some code. So as I mentioned here before, this is the code that we were talking about in terms of the main function, right? So when we read input, remember, if I look at that method, read input will instantiate another object of the scanner class, right? It's going to instantiate an object and then prompt me for all this stuff, right? Notice how this method does not return anything. In this case, read input is a void, so it's not returning any value. But what we are doing here is we're setting the values of month, day, and year. So month, day, and year are going to be set as part of the properties, right? And now we don't have a problem because we don't have to expose them. Okay? So remember, we can set the properties inside the class. That's no problem. As long as if these properties are private, we can access them inside the class, but we can't access them outside. And because we can access them inside a class, it belongs to this class, I can set them in any method inside my classes. So in this case, we're doing a next int, and next int, and we're setting the month, day, year to whatever the user is typing in for each one. Okay, so let's take this for a test drive. Okay, so it says here, enter month, day, and year. Please do not use a comma. So I'm gonna write in July 4th, 1776. Okay, so I'm not using a comma. So remember, space will be the delimiter for scanner for my next function methods. So I'm going to press enter. Oh, what happened here? Section in main thread. Okay, sorry, I know what happened. I put in a th for the second input. So if we look at here, second input is actually an int, not a next, right? Remember, month is a string, and that's getting extracted from July, and then the 4 is a day, and I put th for th, and that gave me an exception. So let me try this again. Press enter, and then there you have it, right? So after I press enter, right? Remember, this is a void, so it's not returning anything. The program will now get the day, because remember, it was set when I read the input. Okay, we get the day number, and then we just print it out, right? That is the 4th day of the month. So whatever I enter for the day on read input now will get saved in these instance variables here. So you have to also remember that if you set it in any method, it's similar to a global when you declare an instance variable, where if you change the value in any of the methods, it will stick with that value as long as that instantiated object lives in memory. So let's take a look at that, of what's happening here. Okay, let me pause this. So remember, over here we read the input. At this point we set day, right? So if you look at the code, we can see that day was set when I typed in the input. And then after we call get day, right, this date 1 is represented somewhere here. As I said, when we instantiate an object, we have not gotten rid of it. So if I set an instance variable here, it's not going to go away. Okay, it's not going to go away until program ends, which means that once I set it, it's still live and available to us through this method getDay. Okay, so on the next video we'll continue this lesson on object-oriented programming and using instantiation of objects, and I'll come up with a couple of more examples, and I hope you join me in the next lesson.